Welcome to my project bazaar. Our project title is Secure Overlay Routing Using a Key Pre-Distribution, a linear distance optimization approach. Let us see the abstract of our project. The key pre-distribution algorithm have recently efficient alternative of key management in today's secure communication landscape. Secure routing technique using a key pre-distribution algorithm requires special algorithm capable of finding optimal secure overlay path. To the best of our knowledge, the literature of a key pre-distribution system is still facing a major void in proposing an optimal overlay routing algorithm. In this literature work, traditional routing algorithms are typically used twice to find a network layer path from the source node to the destination and then to finding the required cryptographical paths. In this paper, we model the problem of secure routing using a weighted directed graph and proposing a Boolean linear programming problems to finding the optimal path. Alphabetic, the fact that the solution to Boolean LP problem are of much higher complexities, we proposing a method for solving our problem in polynomial time. In order to evaluate its performance and security measures, we analyze our proposed algorithm to a number of recently proposed asymmetric key pre-distribution methods. The results show that our proposed algorithm offers great network performance improvements as well as security enhancement when augmenting a baseline techniques. Let us see the system architecture of our project. First, network formation. Here I deployed in the nodes of the networks. Then I finding the network neighbors discovery. The neighbor discovery algorithm is used to finding the neighbor node of each node, then finding the optimal path. The optimal path finder algorithm is used to optimizing the routing path. Here used the routing table. The routing table containing the next best half of the routing. Then performance analysis. The performance analysis containing the throughput, packet delivery ratio, energy, then delay of our project. The next one is flow diagram. Let us see the flow diagram of our project. First, network formation. Here I deployed in the 100 nodes dynamically. Then finding the each node position and distance. If the position and distance is calculated means finding the neighbor node. The neighboring algorithm is used to finding the neighbor node. The neighbors nodes containing the node number, then distance of each node, then the position of node. The position of node containing the x-axis and y-axis of each node. Then analyzing the security. If the encryption and the decryption messages is done here. The source node encrypting the communication and the destination have an unique key to decrypting the value. If the key is matched means the value is shown. If the key is not matched means the message packet is not open. Then finding the optimal path. If the source to destination communication containing the optimal path to using the optimal path discovery algorithm. Then calculating the performance analysis. The performance analysis contains packet drop, energy of our node, then packet delivery ratio and delay of our project. Let us see the output of our project. First, open the terminal window. Our project coding in folder is SVR. So type the terminal window cd space SVR. This command is used to changing the directory. Then now I run the project. A project run code is ns space main.tcl. Now run the project. Number of network is set 100. The 100 nodes is deployed dynamically in this network. Then each node encryption and decryption value is done here using hashing value. Then optimal path finder is used to finding the next hop of our node. Next hop neighbors node. Now I open the terminal window. Now I open the nav window. This is nav. This is rewind button. This is playback button. This is stop button. This is play forward button. This is fast forward button. This is time simulation and this is speed time. This is zoom in button and this is zoom out button. Now I click the play button, play forward button. Now run the project. Network permission is here. Then neighbor node estimation. The neighbor node estimation in this txt the TF file containing the node, neighbor node and the x position and the y position and distance. The 0th node neighbor node is first. Then the node position is the x value is 164 and the y value is 57. The distance is the 0 to first node distance is 88.43. Here calculating each node neighbors and the distance and the position of every node. Now I explaining the project. Neighbor node estimation is done. Then optimal path is find. Now source and destination is created. 4 is a source node and the 20 is a destination node. The communication is start between the source and the destination. Now the 45 and the 4 is the source and destination. The 5 sends the communication to the 45th node. The 4 is a optimal path to send communication. This is routing path. Next source and the destination is created here. Here I define the 4 source and the 4 destination nodes. I explain the graph. The delay graph is created here. The x graph is calculated here. This is throughput of our project. The time versus node communication is used. This is the energy graph. Starting using the energy is 47 and the 47.3 point is an end of the communication energy. This is packet delivery ratio. Then the optimal path finder. It is containing the time and the number of the node and the transmitting path of the next hop.